Thanks for watching my video today. Let's try to prove another integral representation of dilogarithm. And as li 2x is equal to x times integral from 1 to infinity log t upon t square minus dx dt. Okay, this is another representation of dilogarithm. Now let our integral I to be x times integral from 1 to infinity log t upon t square minus dx dt, right? Then it's our right hand side. Now put t equal to 1 over y, so dt is negative 1 over y squared dy, right? Then when t is equal to 1, then y will be 1, right? When t is infinity, y will be 0. That's it. Here, let's write. When t is 1, y is 1. And when t is infinity, then y is 0, okay? Therefore, I is equal to x times integral from 1 to 0 log 1 over y, because of t is 1 over y, right? Upon 1 over y square minus x over y, negative 1 over y square dy. So simplify this one. Then you get negative x integral from 0 to 1 log y upon 1 minus xy dy. I hope you can simplify this. And again, using the geometric progression, 1 over 1 minus x is sum from unequal to 0 to infinity of x to the n, right? So using that here, then is or I is equal to negative x integral from 0 to 1, and this, because of this, sum from k equal to 0 to infinity log y, this one, xy whole k dy, okay? This is x, this should be x, okay? So negative, so x is constant with respect to y, right? So negative sum from k equal to 0 to infinity, coming out x to the k here x to the power 1 here again. So that's why x to the k plus 1, and integral from 0 to 1 log y into y to the k dy. So using IBP here, IBP integration by parts, then you get I is negative sum from k equal to 0 to infinity x to the k plus 1. So first function log y, different integration of second function y to the k plus 1 upon k plus 1 from 0 to 1 minus integral from 0 to 1, differentiation of first function, then is 1 over y, differentiation of log y is 1 over y, right? Integration of second function, then is y to the k, then is y to the k plus 1 upon k plus 1 dy. Okay, now so I is equal to sum from k equal to 0 to infinity. Here, if you put 1, this is 0. If you put 0, this is 0. I mean, this whole term is 0. This minus and this minus become positive. Sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1. This is constant with respect to y, right? Then integral from 0 to 1 y to the k, this to y to the k dy. So then is sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1 into integration of y to the k is y to the k plus 1 upon k plus 1 from 0 to 1. Therefore, sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1, this and this square, right? Whole square. If you put 1 to the k, 1 to the any power is just 1, minus 0 is 0. Then is sum from k equal to 0 to infinity x to the k plus 1 upon k plus 1 whole square. This k start from 0. This is same as the sum from k equal to 1 to infinity x to the k upon k square. So this summation is what we call the dilogarithm, okay? Li 2x. Therefore, Li 2x is x times integral from 1 to infinity log t upon t square minus dx dt. So hence proof.